same time. Okay, so stem and leaf. I know that I plan to teach Simon's class first thing and then Kylie's second core, but just in case I get pulled or whatever, and Viviana, just so you can kind of see it. So I always tell the kids that stem and leaf is another frequency chart. And I'm trying to see, I don't even think I have it written on here. So I always write, it's a stem and leaf plot shows groups of data arranged by place value in 2 columns. I would put that stem and leaf is also another, like I said, another frequency chart or frequency table. And bring back that frequency means how often. And that with the dot plot, we saw the frequency through the dots. And through the frequency table, we saw frequency under the column frequency. I always let the kids know that stem and leaf is a little bit different. It's a little bit weirder. But that if they'll just listen and participate, it'll get easier. And it's one that we take 2 days to practice. So I would just ask the boys to read me example 1. Henry kept track of the points of each of his words when he played a word game. So just like anything, when you come across graphs, you read them like a book. These numbers represent word game scores. So he played a word and made 15 points. He played a word and made 33 points. He uses a stem and leaf to showcase this. So I write the directions. I always tell the kids, sometimes I'm not going to read it word for word, but you're going to group data by place value. So this is the big thing about stem and leaf is it goes by places. I would ask the kid, what order do y'all think we have to write? And reinforce that the order must be least to greatest. Least to greatest. But notice it says 1, 2, 3. There's no 1, there's no 2, there's no 3. Because you have to sort the numbers, the data, by places. So if you have 2-digit numbers and you separate them, and I always do this with my pencil, separate them. You've got digits in the 1s and the 10s, the 1s and the 10s, 1s, 10s, 1s, 10s, 1s, 10s, 1s, 10s, 1s, 10s, 1s, and 10s. So if you're going to order the data least to greatest, and I would highlight, but I don't have a highlighter, we've got digits that are 10s, and you could call these teens, like 13, 15. I throw that in here because sometimes they question them as teens. We have digits in the 20s, and we have digits in the 30s, which is why you see this, 10s, 30s, 20s. But least to greatest, you're going to see 1, 2, 3, because that's what's in the 10s places, 1s, 2s, and 3s, which seems confusing, I know. So instead of reading all this, I'm going to move down here to actually building it because I think it makes more sense to the kids. So we're going to title it. Again, it's word game scores. So since it's short and sweet, I'm going to use it word game scores. I'm going to capitalize it because it's a title, and these are things I tell the kids. Stem and leaf. This is often when I'll pull a fake, I had fake plants on my counter, but I would point to a plant, or, you know, you could even draw a plant off to the side, a plant, a flower, and say, you know, think about this. When people give you a flower, or I'd point to my fake one, you don't get the flower and go, oh, what a pretty stem. Stems are so pretty. No, we don't look at the stems. Stems are ugly. Blech. We look at the flower and the petals. This is what's so pretty. So in a stem and leaf, it's going to be the same thing. When you look at these graphs, it's not the stem that's important. It's all the leaves that you look at. And this is something I really reinforce because when it comes to their numbers and answering questions, it's all going to come off the leaves. All right, so stems. This line is like this line up here where we're separating into places. So your leaves are going to be your 1s digits, and your stems are going to be the 10s digits. So this one's kind of weird because you don't write 13, 15, 19, and then 22, 22, 27. You have to split them up. Well, when you split these up, we've got 10s, 20s, and 30s. So 10s, these will be your 2, and this will be your 3, because this is 1 10, meaning your 10s. 2 10s would be 20s. 3 10s would be 30s. So on this side are the tens digits, on this side are the ones. So in your tens, you have a 13, 15, and 19. So you're going to write 3, 5, and 9. And that's because the stem connects to the leaf. So you have 13, 15, 19. 13, 15, 19. So even though there are 4 digits across, there are only 3 leaves right here. And there are only 3 numbers because we don't count the stems. They're ugly. Blech. 3 leaves, a 13, a 15, a 19. It's kind of weird. 20s, you've got what? 22, 22, 27. So this is 20. So this is kind of how I tell the kids 22, 22, 27. And you have to write them both times because if you don't write both twos, it's only going to look like there's only one 22. So again, a 2 is here for 2 tens, but 2 tens are 20. So this is 22, 22, 27 because the stem connects to the leaves. And sometimes I kind of draw that. But when we count, we don't count stems because stems are ugly. So right now we have 6 leaves. 6 leaves because we have written 1, 2, 3, 4, 5, 6 digits. 31 and 33. Which one's the least? 31. So 31, 33. Notice that I'm lining up the digits vertically the same. That's because of congruency. Like I can tell right away that which word scores were the least frequent, scores in the 30s, because there are less of them. Now, the one thing that the stem and leaf has that others don't is you have to have a key. And I ask them if they know what a key is. Sometimes they do, sometimes they don't. Most of the time it's a don't. And I might say, well, if you've ever seen, like a map, you've got dots that are cities, stars that are capitals. So I might talk about that. But a key, because if you just gave this chart to someone, they're not going to know how to read this. I mean, it's not going to say tens and ones. It's just going to have these numbers. And you're like, what the heck? So you've kind of got to give a key. So you might say, hey, if you see this 3 line 1, and mine's messy, 3, 1, ugh, poop. So 3, 1, like this, 3, 1. What you're really seeing is 31. So you're kind of telling a reader, hey, this digit with a digit on this side is 15. You can choose anything from the graph to put in your key. It could be 33, it could be 19, but this is a stem and leaf plot. And so questions. Girls, read me the question. Okay, what are we looking for? We're looking for how many different words Henry played according to data. Well, how many words did he play? Well, remember that these digits are scores. He scored 31 points, 33 points, 22 points. So how am I going to know how many different times he played a word? And this is where that doubling comes in. Yes, this is 13 points, but that's because this word scored 13 points, and this word scored 15 points, and this word scored 19 points. So every time there's a digit, yes, it's points, but it also represents a word played in the game. So 3, 4, 5, 6, 7, 8. I point out that there are 8 numerals up here. Do y'all notice how I change my vocabulary too, not just numbers? Sometimes they're digits, numerals. 8 up here. What's ugly? Stems. We don't count stems. Stems are ugly. Look how many leaves there are. 1, 2, 3, 4, 5, 6, 7, 8. 8, 8. It's all about the leaves. Why is it about the leaves, I tell the kids? Well, because when you have this 5, it's not just 5. The 1's already connected. It's 15. So when you're counting the leaves, you're automatically counting the stems, if that makes sense. Boys, read us the next question. Kyla, what do you think is, what should we summarize? Okay, I want a point difference between highest, lowest words. John, what does difference mean? Oh, it's the answer to subtraction, right. They want to know what's different about this score than that score. So if you look up here, if you remember that numbers are written least to greatest, your lowest score is going to be up here. And the lowest one is 13. And your greatest numbers are down here. There's a 31 and a 33, which is the highest, y'all. 33. So to find the difference, we do 33 minus 13. 3 minus 3 is 0. 3 minus 1 is 2. So the difference is 20 points. And then you move along, and this is when I'll ask the kids, okay, what do y'all think I should put first? And they might say least to greatest. I would say, well, I think, when you get a book, you usually look at the title. So I'm going to start with the title. There's a lot of numbers here. It says numbers of floors of high-rise buildings. That's a lot of words. I don't want to write that many. Number of floors of high-rise buildings. So, number of floors in buildings. And I tell kids, when you do a title, little prepositions like of and in, we don't capitalize them unless they're the first word. This is when I usually talk to the kids about what are floors. Like a lot of them don't understand this, but I'll tell them if you're on a building and the elevator can go up 8 floors, that floors are each level of a building. So we usually talk about that for a minute just to make sure they understand. All right, and then I'll ask them, okay, have you been listening? What order should we write our digits in? Yes, very good. Least to greatest. All right, well, remember stem and leaf. If y'all don't remember, look right here. It separates by places. So if we have 2-digit numbers, we're separating into ones and tens. Ones and tens. Ones and tens. Well, the stems, same thing right here. If this were a number, this would be the ones. And on the left, we would have our digits in the tens. So I'm going to look at tens digits. I see 3s. I see 2s. I see 4s. Do y'all see anything else? All right, so we have 2s as in 20s, 3 10s as in 30s, and 4 10s as in 40s. So least to greatest. We don't write 20. We write 2 as in 2 10s, which, yes, we're going to know are our 20s. 3 as in 3 10s, which are 10, 20, 30. And 4 10s as in 10, 20, 30, 40. Least to greatest, 20s, 30s, 40s. All right, 20s. Look at all the 20s. What is the least 20? And I see a 26. So I see, and I usually grab a few at a time. Like I'll say 126 and 2 27s. Y'all mark that out. All right, so we already have 2 here. So 2, 6 for 26. And then 2, 7, 27. And then we saw 27 2 times, so we need to put it on here twice. So that's 26, 27, 27. 3 digits. What else do we have in 20s? We have a 28. And we have a 29. All right. 28, 29. 30s. I flat out see 30 right here. So we have 130, and we have 131, and we have 132. So we have a 30. Notice how I'm lining it up to be equal. 30, 31, 32. There's another 30. Look at that poop. All right, so that's going to have to be 0. That's a 1, and that's a 2. Sorry. So 0, 30, 30, 31, 32. So here's 133, 2 33s, and 134. So 33, 33, 34. A lot of 30s. I see 38s and 137, and then 1, 2, 3 38s. So 37, 38, 38, And then 139. 39. And then 40s, we have 140 and 1, 2, 3 43s. So 40 and then 43 once, 43 twice, 43 three times. Sold 43. Wonder how many of them would get that. I don't know what the heck that is. And then 2 45s and a 48. 45, 45, 48. All right. A lot of digits. I bet I could ask y'all a question right now, kids. What is the most frequent, let's see, what range, I'm trying to think how to word this. I know what I want to word. What's the most frequent range of floors in buildings? Do most buildings have 20 floors, 30 floors, or 40 floors? What's the most frequent? 30s. How do y'all know that? Yeah, there's more numbers. So you're going to see frequency on a stem and leaf by, like, the longer the leaves, the more frequent it is. I might ask this. What is the least number of floors in the buildings that were studied? 26. Very good. What is the most number of floors surveyed? 48. How many buildings have 30 floors? I want y'all to think, but don't shout it out loud. How many buildings have 30 floors? Some may say 11, some may say 12. And I'd be like, remember, leaves are ugly. 2, 4, 6, 8, 10, plus 1. There are 11 buildings with 30 floors. So you can kind of just make up questioning, just making sure that they understand. How many buildings were surveyed in all? In other words, how many buildings did they collect data about? I want y'all to think. Don't shout out loud. I want you to think and then raise your hand when you think you know how many buildings did they collect data about. Some kids are going to, not know, of course. They're going to be looking around like, what the heck? Some kids are going to come over here and count the leaves, which I forgot to star. These are the most important. Some kids are going to be smart enough. Well, they might go, okay, 1, 2, 3, 4, 5. And we said there were 11 here, so that's 16, 17, 18, 19, 20, 21, 22, 23. I think I'm missing something. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Which means I missed a number somewhere. Because 23 is not going to make sense. But whatever, if I had a pencil, we would have figured it out. So they're going to say probably 24 or whatever. And go, yeah, how'd you get that? And they're like, well, we counted the leaves. Well, very good. Leaves are what you count. But also, where did all these digits come from? All the digits came from the data, right? So if you have 3 rows, and each row has 1, 2, 3, 4, 5, 6, 7, 8, that's 8 plus 8 plus 8, which is 24. So either way works. And then on the back, tell the kids, oh wait, I know one thing. And then one thing we forgot is the keys. So we're gonna have to draw a key, because this is gonna help a reader figure out what the heck. And you have to be careful about these keys, because I have seen them have decimals in them. So where 31 would have become 3 1/10. So you can choose any number. Like, I'm going to tell my reader, if you come across a 3 stem 4, 3, 4, you're going to read that as 34 floors. And of course, it'd be neater if I weren't videoing, but you get the idea. So you always need a key with these, and always check the key, which is what we're going to see now. So I'm going to tell the kids, STAR test, this is how it's going to look on STAR, A, B, C, D. You don't just jump in and start answering. Check out the chart. All right, class, let's read this together. The data show, and if they get off or, oh, John's not paying attention, let's start over because John's important. This is one thing Tori and I were talking about, is she does the same thing I did. If they're not all participating or if they mess up, start it again. I'm sure y'all do too. But this is 16 students exercise in 1 month. So this is like 18 hours of exercise, 19 hours of exercise. But another thing I read is that there are 16 students. That's because 1, 2, 3, 4 plus 4 plus 4 plus 4 is 16. Because yes, this is 18 hours of practice, but this is one person who exercised for 18 hours. And this is a person who exercised 30 hours. So this is that dual talking, understanding that these digits represent two things. Once I've thought about it, now I'm going to come over here. All right, what are we looking for? We want the stems if we were going to make a stem and leaf plot. Stems. Well, if I were you and this was an assignment and I was lost, I might look back and go, what the heck? Okay, stems. Stems. Oh, they're on the left. Oh, it's the tens digits. Oh, these 10. Okay. Alrighty. So if I were going to make a stem and leaf, stems are ugly, leaves are pretty. They separate them into ones and tens digits because we only have 2 digits. So they're asking what digits would be the stems. Well, what digits do y'all see on the stem sides? 1s, 3s, 4s, 2s. 1s, 2s, 3s, 4s. All right, well, what order should we put them in? Yeah, least to greatest. So it'd be a 1 as in tens, 2 as in 2 tens, 3 as in 3 tens, and 4 as in 4 tens. So the answer is C. They try to trick you on B by putting 0. Well, there aren't any zeros. Why do you think there's so many digits on A? Because we know that's not how many stems there are. Why do you think they put A? A's there because if you're looking at leaves, you're going to find all those numbers. All right, what are we looking for, everyone? I want y'all to scan number 6. What are we looking for? We want a stem with most leaves. Well, remember the stems branch off into leaves. So basically they're asking, what would have the most number of leaves? The 10s, the 20s, or the 30s, or the 40s? Let's look. Let's just mark through. Let's count how many of them start with a 1 in the tens place. 1, do y'all see what I mean? 2, 3. So there would be 3 leaves in the tens. 20s, y'all mark off 20s as y'all count. 1, 2, 3, 4, 5, 6, 7, 8 20s. 8 leaves would be 20s. 30s would have 1, 2, 3 digits. And we'd have 1, 2 in the 40s. So which stem has the most leaves? What's the most frequent? 20s. So stem 2. So see, once you kind of see how to read these, they're not that bad. All right, let's read this one out loud, guys. All right, if I wanted y'all to circle 4 words, they would be how many more than. How many more are here than here? In other words, we want to know what's different. And this is where a lot of times I'd stop and look at them and go, if I want to know how much longer this river is than that one, I want to know what's different. If I want to know how much taller this mountain is than this mountain, I want to know what's different. So this is a difference, which means subtract. So than, dun, 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 versus, this is the 50-yard line. One team is over here. On this side of the field are the leaves. There are 4 2s versus 3 and 4 combined. Now, if I combine my hands, I'm putting them together. So I want to know the leaves are there for 2. Well, if we looked here, there would be 8 leaves with the 2s. So one of my digits is 8. Versus, on the other side of the field, 3 and 4 combined. Well, how many leaves would be with 3? 3. And how many would be with the 4s? 2s. And if you combine those, that makes 5. How many more is 8 than 5? 3. And then, of course, like this one, how many leaves are on the stem and leaf plot? I want leaves on stem and leaf. Well, they have to understand. I would ask the kids, well, where are the leaves? Because they didn't split it up. How many of these digits would be leaves? Hopefully, if they've been listing all of these digits would be leaves, because even though they get separated into places, every number has a stem and a leaf, a stem and a leaf. So if there are 3 rows of 4, 3 groups of 4 is 12. We want which could be a key for this plot. Well, it says 2, 2 is 22. Is there a 22 on this plot? Yep. It says 3, 2 is 23. Oh, why is that wrong? We haven't even looked over here. Oh, you're right, because 3, 2 would be 32, not 23. Same thing, 21 would not be 12. Same thing here. So A is the right answer. And then the last one, you want to know leaves in 12 and 4. How many leaves are in the plot for 12 and 4? There's 1, 2, 2 12s, and there are 2 14s. 1, 2, 3. So how many leaves are in the plot for 12 and 13? There would be a total of 5 leaves, because it would have looked like this. 12, 12, 14, 14, 14. 12, 12, 14. See what I mean? That would be stem and leaf plots.